Welcome everyone. For today's prep video, we're going to start looking at how to estimate the value of a derivative using graphical means. So let's see how to do it. We're going to look at an example. Nice easy function here. Our function is going to be f of x equal to x squared. And we have the graph, and we're interested in figuring out what the value of the derivative is at x equals 1. So we have the graph of our x squared function here, and we want to get this derivative. Well, anytime we're doing something with a graph, it's an estimate. So this is just going to be an estimate for our derivative, but let's see how to do it. So the first step is to identify the point that we're interested in. So in this case, we're interested in what's happening at x equals 1. So first step, identify the point. And we want the point on the curve. All right, so let's just make that nice and big so we can see where it is. There it is. We find x equals 1, and we find the corresponding point on our curve there. All right, so we got our point, and then the next step is to draw the tangent line at that point. All right, so next step, we're gonna draw the tangent line to our curve at that point we just drew. So when we draw this tangent line, it helps. Let's zoom in on the point. So we're really gonna focus in on that point, and we wanna remember that the tangent line should look very similar to our curve at that point, and almost like they're going in the same direction. And actually, if we really zoom in on that point, if we really get close, the curve itself almost looks like a line segment. So we just want to kind of capture that in our drawing. So it helps kind of zoom in really close to our point of tangency. And we're going to start by just drawing a little line segment here that is going in the same direction as our curve. So it's going through that point of tangency, and it really looks very similar to our curve there. They're both kind of going in the same direction. All right, so getting that line segment down helps us, but we do want a nice kind of extended tangent line. That normally helps. So let's extend this out a bit. So we're going to just kind of enlarge this. But we want to keep that same behavior right around that point of tangency. So we just kind of want to extend this out in this direction and extend it out maybe a little bit in the other direction. And when we do that, let's see what we get. That looks pretty good. All right, so that's our tangent line. So we got our tangent line there for our curve. All right. So now we want to estimate, next step, we want to estimate the slope of that tangent line. Again, anytime we're using a graph, it ultimately is an estimation. So estimate the slope of the tangent line. So when we do this, in order to figure out the slope of a line, we need 2 points. So, and we want the slope of our tangent line here. So we want to pick 2 points that are on that line. Well, we already get one for free. So that point that we drew our tangent line at, that's already one point that we can use. So what are the coordinates for that point? Well, in this case, they're 1, 1. All right, so we need to pick a second point that's sitting on our line and, make it easy on ourselves. So we want to look around, and you want to pick a second point that goes through, maybe 1 or 2 grid lines. So we have all these nice grid lines that are drawn here. Let's pick a point that might be easy or easier to read the value for. And if I'm looking, let's kind of scan out through our line. That point looks pretty good. The point at x equals 2. And if you don't find one right away, well, maybe extend the line out a little further, and then you find one. But this looks pretty good right here. So what are the coordinates for that point? Well, the x-coordinate is 2 and the y-coordinate is 3. So that point has coordinates 2, 3. And then once we've identified our 2 points, now we can actually just use our slope formula for the slope of a line. And if we remember, slope is, well, change in y over change in x. So it's the difference of the 2 y coordinates divided by the difference of the 2 x coordinates. And if we plug in our y coordinates here, we end up with 3 minus 1. And then our x coordinates are 2 minus 1. So this ends up being 2 over 1 or 2. And this estimate here, this slope that we just estimated, that's our estimation for our value of our derivative. So we just did it. And so that x equals, or this slope of 2, that's our estimate. And we're doing an estimate here, so we'll use approximately. All right, so that's really the idea. Identify the point on our curve, draw the tangent line to the curve at that point, and then pick a second point that's sitting on our tangent line. So just to really emphasize this, the first point that we have, the point that we identify in step 1, this is on our curve and it's on the tangent line. The second point that we pick is only on the tangent line because we're trying to estimate what the slope of that tangent line is. We don't want to pick the second point to be on our curve, because if that's the case, then the line we draw connecting those 2 points, it's not the tangent line anymore, it's a secant line. So we want to make sure we identify our point where we're going to draw the tangent line. We draw our tangent line, and then we want to pick a second point that's on the line. It's not going to be on our curve normally. And then we estimate the slope of our line. Now, we could have used this change in y over change in x formula, but we can also kind of think of this graphically as well. So another way to estimate what this value is, if we look, again, we can think of slope as really change in y over change in x. And what we do, if we're starting at this point and we want to make our way to this point, well, what happens? Our change in x is we go over 1 unit. So our change in x is plus 1. And then what's our change in y? Well, we go up 1 unit, and then we go up a second unit. So we have a change in y of plus 1, and then another change in y of plus 1. So to get from this point to that point, we go to the right 1 unit, and then we go up 2 units. So if we're thinking of slope as change in y over change in x, we end up with 2 over 1. And precisely what we got before. So this is really how we do it. We draw the tangent line, estimate the slope of the tangent line, and then that's our estimate for the derivative. So we'll try a few more examples like this out in class. So we'll see you then. Bye-bye.